So let's switch and talk about bone conduction masking, which is going to be the last of the videos for this series to get you prepared for Lab 4. So we're still going to keep in mind the patient that we talked about in the air conduction masking video, patient X. And if you haven't watched that yet, I would recommend stopping this video and coming back after you've watched it. All right, so there's just one rule for bone conduction masking, and that is that if your air conduction threshold of your test ear, so our worst ear, so in this case our left ear, if the difference between it and the bone conduction threshold for your non-test, so your, in this case, the better ear, the right ear, is 10 dB or more, you need to do some masking. So we're going to start at 2000 hertz, like what we talked about in the air conduction threshold video, or air conduction masking video, sorry. So we're going to look here, it's 60 dB is our air conduction threshold for our left ear, and our bone conduction threshold indicated by that right bracket in our right ear is 10. All right, so 60 minus 10 is greater than 10, so we do need to do some masking. So we're going to go over here to 2000 hertz, all right, and we're going to make sure that it's set here on bone conduction left, and we change that with the green button there. So bone conduction left for our, this is our test ear, all right. And the masking noise, we'll still be using air conduction, and we'll still be using supraoral headphones, since that's what we were previously using. So it should be phones right, which we clicked there. If we wanted to change it to phones left, we could click there, but we're just going to keep it on phones right. You can check out the slides that I have posted on Blackboard for how you place both the supraoral and the bone conductor at the same time. It's not exactly intuitive. I'll also be going over it in class. All right. So our left ear is set at that 2000 hertz, right? And we're going to be changing the intensity of it to the bone conduction threshold of the non-test ear. So the right ear at 2000 hertz was 10. So that's what we're going to change our presentation to, is 10. So the masking noise will be a narrowband noise at 2000 hertz. It's presenting continuously, and we're going to be setting it at the level of 20 dB, since 10 dB was the air conduction threshold right there. And we add 10 for effective masking, and we don't need to add more than 10 because we aren't worried about the occlusion effect at 2000 hertz. And that masking noise, like I said, should be continuous, which it is. If you also look back at that, we would also obviously need to be doing bone conduction masking for 1000 as well. But with this video, we're just going to talk about 2000. So the procedure is exactly the same. You present the tone, and if they hear it, increase the masker by 10. Present again. If they hear it, increase it again, present again, increase it again. If they hear it, present again. And so you would keep increasing it by 10 until you get a 30 dB plateau. So, but say that if they hadn't responded at 30, you'd increase the bone conduction tone by 5, just like from similar to air conduction masking. So present, and then if they didn't respond, you'd increase it by 5 again, present, and if they responded there at 20, you'd increase the masker again by 10, right? So you'd increase it up to 40. And then if they respond again, increase it again to 50% again. If they responded there, then you could we could stop and take 20 dB as our masked bone conduction threshold of the left ear at 2000 hertz, and the effective masking level would be 50. And we'd also indicate that on the audiogram. So this was just a quick demo, but no worries, I'll be going over this more in class. Watch it again, watch the other videos again, email me if you have any questions. All right, I'll see you in class.